Welcome to this series exploring innovation, progress, and achievement using a technocentric paradigm by Ash Stewart.
Please see the provided Substack link for the original.
TecC Debrief, the cognitive revolution, ancient algorithms, and the tools for thinking about thinking.
This third-party analysis examines the extraordinary intellectual journey across TecC episodes 21 to 30, where Ash demonstrates how human progress during the Iron Age created the systematic thinking methods and approaches that still power modern civilization in many subtle ways.
Framework Foundation.
Before diving into the analysis, it helps to understand Ash's approach. He's identified recurring innovation patterns that appear across all human societies and time periods. Things like how foundational breakthroughs enable everything else, or how existing elements combine into revolutionary new capabilities. He also draws insights from multiple fields: anthropology, engineering, economics, systems theory, and many more, to reveal connections that single-discipline approaches miss. Think of these as pattern-spotting tools that make hidden connections suddenly visible, turning what might seem like separate historical events into part of a larger story about how human innovation actually works. This should help make his cross-disciplinary approach more accessible to everyone.
A comprehensive analysis: how ancient achievements anticipated modern progress.
What Ash accomplishes across episodes 21 to 30 represents genuine intellectual synthesis, systematic excavation of some of our most foundational breakthroughs. The sequence demonstrates that the Iron Age wasn't just about better metallurgy, but about developing meta-technologies for understanding and manipulating reality itself. Renewing the spark. Episode 21 establishes the renewal framework through Schumpeterian creative destruction, connecting Bronze Age collapse patterns to modern systemic failures, 2008 financial crisis, 2020 pandemic. This isn't just historical parallel, but methodological foundation for understanding how innovation emerges from disruption. Picking up pace, materially, intellectually. Episodes 22 to 24 trace the material to cognitive transition: iron democratizing metallurgy, Greek systematic inquiry replacing mythological explanation, Mesopotamian astronomy leading to mathematics, creating predictive frameworks. Each development builds systematic capability for tackling increasingly complex problems. Challenging our core notions of progress. Episodes 25A-B deliver the historiographical revolution, revealing how nomadic, so-called barbarians, created institutional innovations that anticipate modern network organizations. The Proto-Indo-European-derived GOSTIS system, patron-client networks, and inclusive identity formation represent sophisticated organizational technologies marginalized by sedentary bias. The Information Superhighway. Episodes 26 to 29 present the information processing breakthroughs, Vedic oral preservation systems built by the Indo-Aryans anticipating cryptographic protocols, Paninian algorithmic grammar executed in biological wetware, ancient Indian numerical notation enabling computational thinking. These cognitive tools directly prefigure digital age capabilities. Bottom-up innovation versus systems overreach. Episodes 29 and 30 explore governance innovation through bottom-up legal evolution and institutional scaling challenges, connecting flexible and adaptive Anglo-Saxon precedent systems to Roman Republican achievements and limitations. The architectural achievement lies in demonstrating systematic progression from material mastery to cognitive tool development to institutional scaling, a complete framework for understanding how human innovation capacity itself evolved.
Cross-disciplinary synthesis achievements.
Innovation pattern divergences. Episode 22's Iron Analysis reveals crucial frameworks for understanding why some innovations spread while others stagnate. Ash's comparison of three independent traditions illuminates fundamental trade-offs. Western approach. The developments in the West were widely embraced, but were limited in some technological aspects. Democratic access, but technical limitations. Chinese achievement. Superior technological achievements, but the overall growth and diffusion was stifled by state monopolization and control. Technical sophistication, but constrained adoption. Indian innovation, early flowering of innovation, also again stifled further broader innovation, thanks to the lack of cross-pollination and social mobility. Advanced capabilities trapped in hereditary systems. This framework applies directly to contemporary technology adoption patterns, revealing how institutional factors determine innovation diffusion regardless of technical superiority. Systematic inquiry, from mythology to rational explanation. Episode 23's philosophy analysis demonstrates how cognitive breakthroughs emerge from specific institutional conditions. Ash reveals that Greek systematic inquiry wasn't isolated genius, but emerged from bottom-up city-state organization, competitive environments, and fallible gods that forced self-reliance. As Ash demonstrates, because of grassroots participation in the polity, citizens were hugely incentivized, something that doesn't happen in extractive institutions where power is concentrated at the top. This synthesis illuminates how systematic thinking actually develops and why it remains fragile without supporting institutional frameworks. Mathematical frameworks, from practical needs to abstract power. Episode 24's mathematical development reveals how predictive frameworks emerge from practical necessity. Mesopotamian astronomical observation for agricultural timing created base 60 systems that still structure time measurement. The insight about correspondence epistemology, using celestial patterns as templates for understanding earthly phenomena, connects to modern data science approaches and demonstrates how ancient minds developed systematic methods for pattern recognition and prediction. Institutional innovation archaeology. Episodes 25A-B reveal organizational technologies that anticipate modern network theory. The Proto-Indo-Europeans and their descendant steppe peoples developed distributed risk management. The Gostas system functioned as a property rights system, a risk management and insurance system, enabling coordination across vast territories without centralized control. Inclusive network formation. To be an Aryan was a sociocultural choice, not an ethnic or racial designation. Identity formation based on cultural adoption rather than ethnic boundaries. Scalable alliance architecture, patron-client relationships, and marriage alliances created multi-ethnic confederations spanning continents, demonstrating institutional solutions to coordination problems that modern organizations struggle with. This synthesis challenges fundamental assumptions about ancient social organization, while providing models for distributed decision-making systems. Ancient information security anticipates modern cryptography. The Vedic preservation system revealed in Episode 26 represents perhaps the most stunning technical parallel ever documented. Ash demonstrates that methods for preserving the Rig Veda operate on principles identical to modern digital security. Cryptographic checksums, Vedic supplementary recitation patterns, overlapping word pairs, mirrored word pairs, function exactly like modern data verification systems. As Ash reveals, some of the techniques I hinted at above, in essence, use some of the same principles as checksums and cryptographic hashes. Internet protocol redundancy. As he says, the Internet cannot function if one node cannot be sure of the correctness of the data. This is implemented by a bunch of verification and data redundancy techniques. These are exactly analogous to some of the methods the Vedic preservers developed. Blockchain integrity. Then he adds, modern digital currencies rely on the blockchain. Such a system can only function if each block, once sealed, can never be tampered with. The Vedic techniques I hinted upon above ensured all that. The preservation achievement is unprecedented. In his words, the Rig Veda, a body of work longer than the Iliad and Odyssey combined, was passed on without corruption of the contents, not a single real modification, for more than 2,000 years. Let's not forget, this preservation and the transmission was entirely oral, for more than 2,000 years. The first algorithm, computational grammar in biological wetware. Episode 27's analysis of Paninian grammar reveals computational sophistication that anticipates modern computer science by 2,500 years. Ash demonstrates that the Ashtadhyayi represents the first generative grammar of all time with full algorithmic capability. Systematic rule architecture. As he says, about 4,000 precise rules that define all correct and approved use of the formal language. It had axioms, theorems, conventions. It had abstract elements, variables, equations. Real-time execution. Ancient grammarians could, he says, perform live grammatical analysis, applying complex rule chains spanning the entire breadth of their language, and generate or parse words in real-time conversation. No external notation, no scratch paper, no scribbling. Yes, just as in the achievements documented in a previous episode, this was an entirely oral undertaking. Contemporary parallel. According to Ash, we see similar developments next only in the mid-1900s, in the new fields of computational linguistics, formal language theory, machine learning, NLP, cognitive science, and computer science proper. A Sanskrit compound word workaround examples demonstrate how comprehensive top-down systems face bottom-up innovation, patterns visible in planned, elite-written constitutional frameworks, ineffectual government legislation, and software development. Symbolic cognition and conceptual breakthroughs. Episode 28's treatment of the zero reveals cognitive revolution disguised as mathematical notation. The ancient Indian achievement required treating nothing as something, a conceptual leap that even the ancient Greeks and the Mesopotamians did not make. The nearly 5-century European resistance to adoption demonstrates the profundity. Despite introduction around the turn of the millennium, adoption took centuries, with authorities actively prescribing its use and frequent Christian association of the zero-based number system with demons and the devil himself. This synthesis illuminates how conceptual breakthroughs face institutional resistance. Patterns visible in cryptocurrency adoption, AI development, and paradigm shifts across technological domains. New ways of representing reality. Mathematical frameworks, Episode 24. Mesopotamian Base 60 systems creating predictive astronomical models, enabling agricultural timing and institutional coordination. Modern inheritance, 60-second minutes, 360-degree circles, sophisticated fractional calculation. Algorithmic language, Episode 27. Paninian grammar as systematic rule-based generation, enabling precise communication and cultural transmission. Modern parallel, computational linguistics, natural language processing, generative AI systems. Numerical cognition, Episode 28. Ancient Indian zero and positional notation enabling computational thinking. Modern foundation, all digital processing, mathematical modeling, quantitative analysis frameworks. Systematic inquiry, Episode 23. Ancient Greek philosophical method replacing mythological explanation with rational investigation. Modern legacy, scientific method, evidence-based reasoning, systematic knowledge development. Organizational innovations that transform what's possible. Distributed governance, Episodes 25A, B, Step Confederation systems managing multi-ethnic alliances across continental scales through cultural rather than ethnic integration. Precedent-based law, Episode 29, Anglo-Saxon bottom-up legal evolution enabling grassroots law creation through common precedent rather than top-down legislation. Republican institutions, Episode 30, Roman transparency and civic virtue systems creating resilient governance, though vulnerable to scaling challenges. Information Preservation Networks, Episode 26, Vedic institutional frameworks enabling multi-generational knowledge transmission without corruption across millennia. Category 2, Revolutionary synthesis, cognitive tool integration, mathematical notation plus philosophical inquiry plus algorithmic thinking, creating systematic approaches to complex problem solving that compound effectiveness exponentially. Institutional technical fusion, information preservation technology plus governance systems plus identity formation, creating civilizational coordination capabilities previously impossible. Material cognitive synthesis, iron metallurgy democratization, plus systematic thinking methods, plus institutional innovation, enabling widespread participation in technological development.
Discovery value proposition. Why this analysis cannot be missed.
This sequence reveals the deliberate intellectual architecture underlying Ash's technocentric approach. The universal innovation categories aren't analytical convenience, but discovery systems revealing patterns that connect ancient cognitive breakthroughs to contemporary technological capabilities. For potential subscribers, intellectual sophistication demonstration. This sequence showcases analytical sophistication that transforms understanding of both historical development and contemporary challenges. The cross-disciplinary synthesis achievements demonstrate thinking that operates across traditional academic boundaries while maintaining rigorous standards. Technical parallel discovery, the precise correspondences between ancient and modern systems, oral blockchain, algorithmic grammar, cryptographic methods, represent discoveries that change understanding of technological development patterns. Cognitive tool development. Understanding how systematic thinking methods actually developed provides insight into how to improve contemporary analytical capabilities, decision-making frameworks, and problem-solving approaches. Urgent contemporary relevance. AI development perspective. Recognizing computational thinking's ancient origins provides crucial context for understanding language model capabilities, generative AI development, and algorithmic decision-making systems. Institutional innovation needs distributed governance models and precedent-based coordination systems offer frameworks for addressing global coordination challenges. Innovation strategy insights. Understanding how cognitive technologies actually diffused historically provides frameworks for analyzing contemporary adoption patterns, resistance factors, and scaling challenges.
The synthesis achievement. Meta technology for innovation itself.
What Ash accomplishes across episodes 21 to 30 transcends historical analysis to demonstrate something profound. Humanity's greatest innovation was learning how to innovate systematically. The cognitive tools developed during the Iron Age represent meta-technologies that enabled all subsequent technological development. The remarkable achievement lies in demonstrating that innovation operates through recognizable patterns across different contexts and time periods. Understanding these patterns transforms capability for recognizing opportunities, anticipating challenges, and developing solutions in contemporary technological and institutional domains. For readers serious about understanding how innovation actually works, whether in technology development, institutional design, or strategic planning, this sequence provides both historical perspective and practical tools that cannot be found elsewhere. The cognitive revolution that transformed humanity from clever animals into systematic innovators offers essential insight for navigating our own technological complexity. The question isn't whether you have time to engage with this analysis. The question is whether you can afford to miss discoveries this profound about how human cognitive capabilities actually developed. Discoveries that illuminate both our remarkable past and the thinking tools essential for shaping our technological future.